Hello student, good morning. I am Dr. Ajay Kumar Sinha, Professor of Chemistry. Today I will continue from the last class. Last class I have started a review of fundamentals of first chapter, that is atom, molecules and chemical calculation or chemical arithmetics. Under that I have discussed significant figures. Now I will discuss about SI units. The SI units of some common physical quantities are, first one by one I will tell you. Actually you might be knowing some, but here in the beginning I will brief all the physical quantities. Okay, SI units of physical quantities. First, for the length it is a meter. It is represented by a small m. Mass, I am talking about SI unit, international system. Then for length it is a meter, a small m, and mass is kilogram, means kg. Time, that is a second, a small s. Temperature, Kelvin, capital K. Now others are new for you. Electric current, its unit is ampere, capital A. Amount of substance, that is equal to moles, 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 but it is written as, in IUPAC it is written as MOL, mole. Okay, amount of substances, that is equal to moles, and moles is written as in SI unit MOL, mole. And luminous intensity, that is a candela, CD, candela, CANDELA, candela. And for volume it is a cubic meter, m power 3, a small m power 3. And density, you know, this is mass by volume. Then mass is equal to kg divided by volume. Volume is equal to m power 3. Then you can write kg m minus 3, m power minus 3, kg m power minus 3. Okay, and velocity, that is a meter per second, a small m, second means inverse s minus 1, m s power minus 1. Actually to write the unit, you know, formula you should write and then you put the unit. First you should write the formula and then you write the unit. Okay, what is the formula you should write, and then unit you write. Then you can, after that you can write in a all. If it is down, you can write up by putting minus sign, like minus 1, minus 2, minus 3. Okay, upside what is there, that is the power 0. Correct? Then here velocity is meter per second. Meter, m by t, t is the time. T is the time in second, then meter per second, that is the velocity. Meter per second, m s minus 1. Like that way, other also you can write. Force, what is the SI unit for force? Very important, that is the Newton. And it is denoted by capital N. Newton denoted by capital N. Pressure. Pressure, SI unit of pressure is Pascal, PA, Pascal, or also it is known as Newton per meter square. Newton per meter square. This is the pressure unit I am telling you. Pressure is equal to Pascal, means PA, capital P, small a, PA, or Newton per meter square. And work, work is also called energy. Then work or energy, its unit is joules. Joules, Joules, joules. And it is indicated by J. It is indicated by J. Okay. Then this I have told about the SI units. Now, what is the subsidiary units? Subsidiary units. These are either multiples or fraction of the base units. You remember, subsidiary units are either multiples or fraction of the base units. Then example I am telling for deci. Deci means 10 to the power minus 1. Centi means 10 to the power minus 2. Okay. Milli means milli is equal to 10 to the power minus 3. Micro is equal to 10 to the power minus 6. Nano is equal to 10 to the power minus 9. Pico is equal to 10 to the power minus 12. And femto is equal to, femto, it is uncommon, FEMTO, femto, that is equal to 10 to the power minus 15. And Fermi, that is equal to 10 to the power minus 13 centimeter, that is called Fermi, or you can tell 10 to the power minus 15 meter. Centimeter can be converted into meter. Then Fermi is equal to 10 to the power minus 13 centimeter, and that is equal to 10 to the power minus 15 meter. Now other subsidiary units I am telling you. Deka. Deka means 10 to the power minus 1. Hecta, that is equal to 10 to the power minus 2. Kilo is equal to 10 to the power 3. Mega is equal to 10 to the power 6. Giga is equal to 10 to the power 9. Tera, that is equal to 10 to the power 12. Peta, P-E-T-A, peta or peta, you can tell. Peta, that is equal to 10 to the power 15. And exa, E-X-A, exa, that is equal to 10 to the power 18. Okay, sometimes these units are also asked, or during calculation you will require all these units. Now conversion factor I am telling you. Useful conversion factors. Okay, some useful conversion factors, you should remember it. 1 angstrom is equal to 10 to the power minus 10 meter. You remember, this is always you require when you will solve the numericals. 1 angstrom, A power 1, just like a very small 0. Okay, point like that. Then 1 angstrom is equal to 10 to the power minus 10 meter. And 1 nm, nanometer, 1 nanometer means 10 to the power 9 meter. Okay, 1 picometer is equal to 10 to the power minus 12 meter. Okay, and this like that way, 1 liter is equal to 10 to the power minus 3 meter cube, or that this is equal to 1 decimeter cube. 1 liter is equal to 1 decimeter cube. Like that way, 1 liter is equal to 10 to the power minus 3 cubic meter, meter power 3. 1 atmospheric pressure that is equal to 1 atm is equal to atmospheric pressure, that is equal to 760 mm millimeter, or torr, 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 correct. And 1 atm is equal to also 101,325 Pascal. You remember 6 digit, they are take 6 digit. 1 atm is equal to 760 mm, or torr, and 1 atm is also equal to 101,325 Pascal, or Newton per meter square. Newton per meter square. Okay, then this is very, very important in solving the numericals. You will need this. Physical chemistry, when you solve the gaseous problem, that time you require this relation. Then 1 atm is equal to 760 mm, or torr, TORR, and this is equal to 101,325 Pascal, or Newton per meter square. N m power minus 2, N m, and m power minus 2. And bar is also the unit of pressure. Then 1 bar is equal to 10 to the power 5 N means Newton per meter square. Per meter square means m minus 2, N m minus 2 means N upside and down m square. Then you can write N m and m power minus 2. Okay, N m and power is minus 2. That is the 1 bar. 1 bar is equal to 10 to the power 5 N m power minus 2. And this is also equal to 10 to the power 5 Pascal. 1 bar is equal to 10 to the power 5 Pascal. 5. 10 to the power 5 Pascal. That is equal to again 1 bar. Okay. Only units are changing. 10 to the power 5 is same. 1 bar is equal to 10 to the power 5 Nm, and m power minus 2 means Newton per meter square. And that is equal to, in sense of Pascal, same 10 to the power 5, and only for Newton per meter square you are writing Pascal, PA. Next is 1 calorie. 1 calorie is equal to 4.184 joule. 1 calorie is equal to 4.184 joule means J. And 1 electron volt, EV, a small e, capital V, electron volt, EV. Then 1 electron volt is equal to 1.6022 into 10 to the power minus 19 joule means J. It is also energy. You remember, J means joule. A joule means energy. Then 1 electron volt EV, in shortcut EV, a small e, capital V, electron volt, is equal to 1.6022 222 into 10 to the power minus 19 joule. Correct? This I told useful conversion factors. These are used when you will solve the numericals. Okay, and this relation will be very, very helpful in examination hall. Correct? Quickly you can make a change and you can get the answer. Okay. Now I am discussing other things. Matter. Now means whatever I am discussing chapter wise. Correct? All the fundamental things I will discuss, means I am reviewing, and then I will come to the multiple choice question or numericals or new type of question, new type of numericals and other concept. Okay, many things are there which are you are knowing, but question is asked in indirect way. Okay, then first I am now reviewing all the chapter. Then now matter. What is matter? Then anything, you remember, very, very important. All are very, very important terms. Matter. Anything that occupies a space. First things. Possesses mass. This is the second things. And third things, the presence of which can felt by any one or more of our five senses is called matter. We have five senses, you know. Correct? Like eye, nose, ear, our skin, like that way. We have five senses. Then here, anything that occupy a space means solid like things, solid. So solid, gas, liquid, all coming under the matter. Solid, that is all know that solid is the matter. Liquid is also the matter. And gaseous atoms, air, you can tell, air or any type of gas, that is also matter. Correct? And how gas, you know, it is the mixture of different type of gases. Air is the mixture of different type of gases. Correct? And gas, what is the gas? Then gas is made from the different type of atoms or molecules. In case of helium, neon, argon, krypton, radon, xenon, kind of, that is these are the gases, but having one atom, monoatomic gases, you remember. Correct? These are last group 18 I am talking about, inert gases. All inert gases are monoatomic gases. Only one atom is there and they are in gas. Other are in molecular form, like H2, 2 hydrogen is there. Cl2, 2 chlorine atom is there. NH3, 3 total, and 4 atoms are there. 1 N, 3 H. PH3 again 4. SO2, 3. 1 S, 2 O, SO2, SO3, total 4. PCl 5. Correct? 6. Then here you should understand that gases are made from molecules. Some gases made from single atom also. That is the inert gases, the best example for monoatomic gases. Mono means one, single. Then gases are also made from the atoms, and atoms comes under the matter. Okay. Then matter, you can define anything that occupies a space, possesses mass, and the presence of which can felt by any one or more of our five senses is called matter. Here you should understand electron, proton, neutron. They have a mass. Electron have mass, you know. Proton also have mass. Less mass, that is a different. But they have mass. Electron, proton, neutron. Hence, they are also coming under the matter. Correct? That is actually in the form of radiation. It is in the form of radiation, don't forget. Now next is states of matter. States of matter, then you know solids, liquids and gases are states of matter. Now plasma also you know. Now next I am telling you homogeneous and heterogeneous matter. Any material that is uniform in composition throughout and consists of only one phase is called homogeneous. If it is not uniform throughout and consists of a number of phases, it is called heterogeneous. Correct? Homogeneous means one phase. Everywhere throughout it will be uniform and it will consist of only one phase, is called homogeneous. If it is not uniform throughout and consists of a number of phases, more than one, it is called heterogeneous. Next is chemical classification of matter. Chemical classification of matter. First, pure substances, and that chemical classification of matter, and that pure substances. Many times you will tell pure substances means elements and compounds, all homogeneous. In elements, same type of atom will be there. Either gold, every atoms are gold only. That is the element. Silver, all atoms or particles are silver, all atoms are of silver only. Same atoms, same particles. Correct? Then elements and compounds of all homogeneous. Now hydrogen, as for example, H, it is molecule, but both are H. Cl2, both are Cl. N2, both are N, 2N are there. Correct? Oxygen, OO, both are oxygen. Then pure substances means elements and compounds, all homogeneous. Now second, mixtures. Then by name it is clear. Mixture which may be homogeneous or heterogeneous. Homogeneous solution means only one phase. It is a mixture, but you will find only liquid phase or in solid phase or in gaseous phase. Only one phase is there. Maybe mixture of 2 or 3, but they exist only in one phase. Correct? Solution may be mixing of 2-3 things, but they look like uniform in one phase, only liquid. Then that is the example of mixture which may be homogeneous, that is the solution form, or heterogeneous also. Two liquids will mix, then it is homogeneous. Both are liquids. Sometimes in liquid solids are dissolved, but dissolved fully. It became one uniform. But there are two things. Then it is the mixture either of the same or different. Then mixture which may be homogeneous or heterogeneous. Now come to the element. What do you mean by the element? It is a pure substance that contain only one kind of atoms. Only one kind of atoms. Now classification of elements. How will you classify elements? Then elements are classified into metals, non-metals and metalloids. Examples of metalloids are arsenic means As, antimony means Sb, bismuth means Bi. Then antimony, arsenic, bismuth are the metalloids. Question is also asked. Now compound, element I told you. Now come to the compound. It is a pure substance containing two or more elements. Two or more elements in a fixed ratio by weight. It is always homogeneous. It will look like same, homogeneous. Okay. Then compound is a pure substance containing two or more elements in a fixed ratio by weight. It is always homogeneous. Now come to the mixture. Okay. Already I told you it is a material containing two or more substances, maybe elements or maybe compounds in any proportion. Proportion is not fixed. In compound it is a fixed. In compound it is a fixed. But in mixture, no, nothing like that. In any proportion. Then mixture means it is a material containing two or more substances, maybe elements or compounds in any proportion. It may be homogeneous or it may be heterogeneous. Now separation of mixtures. How will you separate? These are the very, very important question is asked. Listen carefully. Separation of mixture. In brief, I am telling you. The different methods are as follows. I am telling you one by one. Filtration. There are 9 methods. There are total 9 methods. Okay, by which you can separate the mixture. 9 methods. I will tell you in brief all. First is filtration. It is common, you are knowing. Filtration to separate mixtures in which one component is soluble in a particular solvent. Correct? Filtration means to separate mixture in which one component is soluble in a particular solvent and the other is not. Correct? One component is soluble in a particular solvent and other is not. Okay? Means in a mixture two are there, one is soluble, other is not soluble. Then that time by filtration you can do. You know that suppose in any liquid in water some dust particles are there, some solid particles are there, small solid particles like a little stone. Then you can filter it. Correct? Filter it. Then liquid will be separated and solid will be separated. That is the filtration. Second is simple distillation. Simple distillation. What is this? Where it is used? Then to separate non-volatile solute. Non-volatile means it will not come in the form of vapor. Non-volatile, solid like that. Then to separate a non-volatile solute from a solution, or to separate a mixture of liquids having large difference in their boiling points. If two liquids are mixed and both liquids have different boiling points, that time distillation is done. Distillation, simple distillation is to, what is the purpose? To separate non-volatile solute from a solution, or to separate mixtures of liquids having large difference in their boiling points, large difference. Now, third, fractional distillation. It is also distillation. Fractional distillation. Then where it is used? It is used to separate a mixture of liquids having a small difference in their boiling points. See, here boiling points are less difference, small difference. A small difference in boiling points, and both are liquids, maybe mixture of liquids, but they have a small difference in their boiling points. Now next is extraction. So many people will get confusion, distillation, fraction and extraction. Now listen carefully. Extraction. What is, where it is used, for what purpose? Then to dissolve out one of the components of the mixture with suitable solvent. Okay. Extraction means to dissolve out one of the components, one, maybe 3-4 component. From that, one you want to separate. Correct? In there it is used to dissolve out one of the components of the mixture with a suitable solvent, because in that suitable solvent any one component will dissolve, other will be in the solution only. Then if any one is separating out from the mixture, any one liquid is separating out from the solution, then there the term extraction is used. Extraction means to dissolve out one of the components of the mixture with a suitable solvent. Now next is fractional crystallization. See, all are similar type. Fractional crystallization. Then where it is used? Fractional crystallization to separate out two solids having different solubilities in the same solvent. Here two conditions are there. Here it depends upon different solubilities. Beginning I told you boiling points, but here in crystallization, fractional crystallization, that solids have different solubilities in the same solvent. Like water. Two components are dissolved, two substances are dissolved, their solubilities are different. Okay, they have different solubilities. Then there this is done. Crystallization, fractional crystallization is done. Then fractional crystallization is done to separate out two solids having different solubilities in the same solvent. Next is sixth one is gravity separation. Then here you might be understood by the term only gravity separation. It is related to heavier. Okay. Then where it is used? It is used to separate a mixture in which two components have different densities. It is related to heaviness. Different densities. Densities means mass by volume. If suppose volume is the same, then if two substances are there, volume is the same, then mass will differ. If densities are differ, and volume is the same, then mass will be different. Then you remember D is equal to m by b, that is the density, that is related to heaviness. Okay, per unit, okay, per ml, per liter, what is the mass. Then here that gravity separation means to separate a mixture in which the components have different densities. Next is magnetic separation. It is by it is again clear, magnetic means it is related to attraction. Then magnetic separation means to separate the components of a mixture, one of which is magnetic and the other is non-magnetic. If both are mixed, then by use of magnet you can separate it. And now eighth is sublimation. It is used to separate the components of a mixture, one of which sublimes and other does not. If a mixture is there but one is sublimate, it can sublime, other can't sublime, then there it is used. Sublimation means one will vaporize, other will not vaporize, means non-volatile. One is volatile, other is non-volatile. There it is used. Okay. Now that is the eighth one. Sublimation, I told you. Sublimation is used to separate the components of a mixture, one of which sublimes and other does not. And last is chromatography. It is used to separate the components of a mixture on the basis of the difference in adsorption on a particular adsorbent. Here it is based on adsorption and adsorbent. Then here you should understand different. Adsorption means it will not go inside. It will be adsorb. It is not absorption. Absorption means everywhere it will uniform. Inside also it will go. Inside of the mass also it will go. Just like water is absorbed everywhere by a solid. But gases will be absorbed only on the surface. When it is absorbed only on the surface, then it is called adsorption. Correct? And this process is called adsorption, and matter on which it is adsorbed, that is called adsorbate. Okay. And gas which is going to be absorbed, that is called adsorbent. Okay. Then adsorbate is the liquid or solvent, you can tell, that will adsorb some component. Then chromatography is used to separate the components of a mixture on the basis of their difference in adsorption on a particular adsorbent. That may be adsorbent, may be solid also. If you pass the liquid, then suppose three components are mixed, then which will absorb more, that will come first, after that second, and then third. Then later on you can separate from the adsorbent. Okay, adsorbate. This adsorbent, from the adsorbent where it is adsorbed, now you can cut it, separate it. You can remove it from the upper portion. Then it was in mixture, now you have separated. Okay. Then this is done by the chromatography, and it is based on the adsorption. Okay, difference in adsorption on a particular adsorbent. Now I am stopping only here. Next class again I will continue. Thank you.